Hello and greetings. Today we will study logic, deductive reasoning. These are the sources and references which I will use during this chapter. So the first one is the logic, the study of deductive reasoning by Cemal Yildirim. It was published by Matthew in Turkey. And then the second book is Logic by Wesley C. Salmon. It's again a lovely book, but the most comprehensive one is the first one here, the Cemal Yildirim's. And I have also had to look some parts from the Thinking Philosophically by Richard E. Creel. This is a general philosophy book, a fundamental starting introductory book, but I would recommend it, but it's not a logic book in itself. So now let's start. As an introduction, let's ask the question, what is logic? Etymologically speaking, logic derives from the Latin word logos, and logos means word, reason. So logic is the study of word and reason, but when defining some words in philosophy, it's actually not quite that straightforward and simple. This is just an etymological background of it. So, where do we put logic? So, there are various approaches whilst thinking that, and actually, it's all the same in various fields of philosophy. And the question is right now, is logic a matter of philosophy or not? Is it a constitute of itself or not? So let's see various approaches to this topic. So here we see the Carnap's way of approach and his scheme here. So he takes the matter in hand in terms of functions of language. He divides it into two: expressive function of language and representative function of the language. So we could say that expressive function of the language is arts and the latter the science. So the system of theoretical knowledge. He puts lyrical verses and metaphysics into arts. So actually it is in science, but he puts an arrow. And for the psychology, is an empirical science under science. So what is empirical science? Where you take measures, you measure, observe, these makes the sciences empirical. And here we see that philosophy and logic actually constitutes the same area. On the other hand, here from the thinking philosophically, Richard A. Creel, we could see a more classical approach of scheme. He divides the philosophy into three matters: reality, value, and knowledge. So, metaphysics, theory of value, and epistemology. And again, these also divide into sub-genres. Here we see that metaphysics deals with humans, nature, God. So, nature, the philosophy of nature, happiness, morality, justice, art. Here we have axiology. And under knowledge, we have validity, meaning truth. And here, validity is seen as logic. So, validity, logic, the same thing. And in this scheme, we can see that logic comes under knowledge, under philosophy. So, and finally, in the Cemal Yildirim's aspect, we see a different approach. He sets it in disciplines of knowledge, not the just. It doesn't just take the philosophy like the others did or function. Here we have philosophy, formal disciplines, and empirical sciences. For example, let's remember here, empirical sciences is under science and different from philosophy, but philosophy and empirical sciences remain under science. But here, they're completely separated. We could see that. Actually, here it is also separated, but not completely. Here, under philosophy, we have metaphysics, theory of knowledge, so epistemology, and axiology. Formal disciplines have logic, mathematics, and empirical sciences, physical sciences, biology, and behavioral sciences. Here we see that logic is not under empirical sciences nor philosophy, but it is next to mathematics. So they are somewhat related and close to each other, and on the other hand, it is still yet too far apart. So we can't just say this is this in philosophical thinking. there are various approaches, and as we have said, they are not contradicting each other, but taking the matter into hand with different perspectives and different categorization. Now, and this was my try of putting logic into a scheme. I thought that the logic was the constitute of all thinking, but I will not go into this. But if you want, you could pause and try to see what I've tried to do if you're interested. But let me tell you a word. I've created some new words like introphysics, extrophysics, like that. So, but I will skip this for now, as it is not in the teachings of anybody. Now, let's start with the fundamentals. So, first, argument. What is an argument? We'll talk about that. And then, validity of these arguments and forms of arguments, and truth, reasoning, inference and implication, quite related and similar. And we have deductive and inductive arguments. So this course will be about arguments actually, and we will have an introduction to deductive and inductive arguments. Now, arguments. Let's first ask, what is an argument? So we talk earlier, right? Arguments. Try to think of some examples right now. Think with me. What is an argument? How can you define an argument? And then the other question is, what is not an argument? Now, debating is not an argument. Disagreeing is not an argument. So let's say that I have a pen here. I have a pen. Is this an argument? No. I have a pen. If I say that this pen is red, is it an argument? And be careful. I'm holding a pencil. And I say that this is a pen. So that has to do with the validity and truth, and we will come to that. So this pencil here is red. No, that doesn't constitute an argument. So for an argument to happen, we need at least two premises. So I need to have a word, a premise, and a conclusion. So, pardon me, not two premises. We need at least two assertions, one being the premise and the other being the conclusion. But the premises could go on. It could be two, three, depends on your argument. But in a basic argument, we generally have two premises and one conclusion, and this is also called a syllogism. And we have two basic types of arguments, one being the deductive argument and the other being the inductive argument. Now, let's see an example. Here, I am tired, therefore I need to rest. So, as you can see, we have two assertions. I am tired, I need to rest. So, if it were only I am tired, it wouldn't be an argument, right? So, I'm creating an argument for my need to rest. I need to rest. Why? Why do I need to rest? Because I'm tired. So I can paraphrase this exact argument in a different matter. So I need to rest because I'm tired. But in logic, we have a generally used type of writing, and this is the so-called one. So I am tired comes first, and then this line separates the premise and the conclusion. So this is the premise. And then this three dots means therefore, so, thus. So it gives me the conclusion here. I am tired, therefore I need to rest. And these two constitutes an argument, a simple one. And now let's see validity. So here we have an example. My first premise, second and third conclusion. Everyone who is tired needs to rest. So everyone who is tired needs to rest. It is a premise, not an argument. This entirety creates an argument. The second premise is I am tired. Oh, so from here I could conclude that if everyone who is tired needs to rest, then I need to rest, right? So But let's see if it is valid. It is valid, right? Because even if I change the people here, it has to be correct. So instead of writing everyone tired we could remove that and I could change it into just verbs. And here we see the form. All A's are B, C is an A, therefore C is B. Here we see the form of it, and the validity has to do with the form actually. So you could write anything here. And now we will see some examples. Now, here, all birds have wings, and I'm sorry, there was a problem that it didn't have to come right now. So let's start. All birds have wings. Sparrows are birds. Sparrows has wings. So the validity has to do with the argument itself, the form, we said, right? Now the truth is to do about the assertions. Now all birds have wings. It is true, right? All birds have wings, we know that. Sparrows are birds. Are they? Yes, they are. And sparrows has wings. Yes, they are. And this argument is valid. Valid because of the form, because I could change the birds with anything else. We could say, all birds have arms. Sparrows are birds, therefore sparrows have arms. This would be valid, but as my statement is false, we would call that an unsound argument. So you can't say that this argument is wrong, this argument is true, false. No. Arguments could be valid or invalid, and according to the assertions, if the assertions are false, we could say that it is unsound. Now, babies are surgeons. Surgeons can't treat, therefore babies can't treat. Now, babies are surgeons. That is a false statement. Surgeons can't treat. That is also false, right? Babies can't treat. Yes, that is true, actually. So you can see that even if these statements are false, we could have a true conclusion. And because that is due to the fact that this argument is valid. So, in order to take these arguments and put it into good use, we have to be sure about our assertions, the premises, if they are true or wrong, or the arguments would not be strong and it would lead to fallacies. And fallacy is an important topic. There are two types of fallacies, formal and informal ones. The formal ones has to do with the forms, and the informal ones change about the approach, and we will have another chapter about that. And here, everyone wears high heels. Whoever wears high heels is stupid. Therefore, everyone is stupid. Now, everyone wears high heels. No, I don't wear high heels, so that is false. Whoever wears high heels is stupid. And no, that is also wrong. And everyone is stupid. Now, as you can say, they are all false, but the argument is valid. So if the statements would have been true, then this would be true also, right? So valid but unsound arguments. Now, let's look at some more examples. Here, humans have two legs, chickens have two legs, therefore chickens are humans. Now, humans have two legs, true. Chickens have two legs, true. Chickens are humans, oh, wrong. Why? Why is that? So what is the problem here? As you can see, if you go back, the validity, it doesn't give if it is sound or unsound, right? But if an argument is valid and the premises are true, then it has to be true. And that's the key point. Here, we see that the premises are true, but the conclusion is false. That is because the argument is invalid. And let me repeat this. In a valid argument, if the premises are true, then the conclusion has to be true. And that is what we call deductive argument. So this is invalid. Why? Because there is a formal fallacy. Humans have two legs, chickens have two legs, but that is not a surrounding factor to give that chickens are humans, right? Because having two legs is not a limiting factor of being a human. It's not the necessity. So here, cars are becoming larger. Larger things are slower. Therefore, cars are becoming slower. Now, we don't know. Like, there has to be a document, right? We need data. Larger things are slower. I don't think so. They are huge airplanes, trains, and they're really fast. So, but you could think of another perspective and like think of a huge fat animal like a bear, whale, and they're slow. So you don't know. It's uncertain. It's vague. And cars are becoming slower. It's also vague. But here, this argument is valid, right? So if you knew that the premises were true, then this has to be true too. So these are vague assertions. And here, birds have wings, ducks have wings, therefore ducks are birds. Now, these are true, right? Birds have wings, and ducks also have wings. But does it make a duck bird? Yes, actually, but no. So how ducks are birds? Yes, that is correct, but it's not because of the wings. It's and still an invalid argument. As you can see, it has the same form as the first one, right? So there is a problem with the structure. We have to take it carefully. At this time, by chance, it may have worked, but if you put other verbs, then it may not work. So this is invalid. And again, we will come to the fallacies, formal fallacies, in the future. Now, what is the key point we are trying to do here? We are all going about the reasoning. So what is the reasoning? We ask why, how it happens. What is the reason you are giving to your argument, right? You say something, actually to your assertions. We could say that this pencil can write. Why? How do you know that? I could say this pencil can write because I have seen many pencils which did write, and this looks really similar to those ones, so I'm assuming that they can write. And actually, the argument which I made right now is an inductive one. We will come to that again. So, but the point I'm trying to make is deductive or inductive. We are trying to put a reason. So, this pencil could fall, right? I leave it and it fell. Why? It fell because of gravity. But this is not a direct argument, right? I could try to create an argument from this. Every object on Earth is under gravity. This is the first assertion. And then the second one, let's say that every object under gravity falls down to Earth. This pencil is on Earth, therefore it falls, right? Why? Because, as we said in the first premise, it is in the direct force of the gravity. So that is a reasoning. Just plain words doesn't create an argument. We need reasoning, and we use reasoning every day in our thinking life. If you go to the markets, if you're studying, if you're driving car, every aspect of it in your life, we are using reasoning. It is what makes humans human and enables us to think. And this is the problem which causes for us to have problems with the new quantum physics also. Why? Because reasoning actually gives us a path to a deductive and determined way of living. So determinism says that everything has a reason, right? or a reasoning cause relationship. But in indeterministic rules, this approach breaks. So that is why we struggle to understand quantum physics, because there is some places where reasoning actually don't quite work. It actually works. We do the math like that, but it is not quite deterministic. A direct reasoning doesn't show us a direct conclusion. And also, there are some problems with reasoning too. We have to take our premises quite directly and carefully. We have to select it carefully. So, Al Ghazali was a philosopher in the Middle East, and he was an important one actually in the area at the time. So he argued and talked about the reasoning very much. So actually, again, whilst I'm thinking, it goes and puts it into other aspects. So, but I will give an example. So, for example, imagine that there is a car, but it is under a blanket, and you don't know what a car is, and you are trying to solve how it works, how a car functions. So you take a hammer and you break one part of it to see which part of the car's body is the functional one, so the heart of the car. So you take the hammer, you're blind, and you break the lights. Oh, the car still goes, right? It still runs. Okay, then you say, okay, this is not the vital part. And then you take another one and then break the glass. Oh, it still works. And then, let's say that you take it and you cut the wires going to the battery. And then you see that the car stops working. And then you reason, oh, I broke something in the car, and the car stopped functioning. Therefore, it must be the main reason behind how the car functions. But that is just a cable. Actually, the main thing which runs the car is the motor, right? But without knowing, you could make wrongly assumptions. And actually, here, the argument is valid. You see, you break the wire, you break the wire there, and the car stops functioning. Before that, it functioned. Therefore, it must be the reason, it must be the cause of it. So we had to be careful whilst choosing what we are taking into our assertions. Now, let's also see inference and implication. So here, Britain is larger than England. England is larger than London. Therefore, Britain is larger than London. Here, I'm inferring that from the first premises. I'm inferring that Britain is larger than London. So what is implication? Implication, again, has to do with the form. Implication still stays there. And I'm sorry, I should have closed the notices. Some sounds came during the last time, so but let's continue. So Britain is, I'm inferring that the Britain is larger than London, and that is has to do with the verbs here. But the implication has to do with the form. I could say A is larger than B is larger than C, therefore A is larger than C. So implication remains even if I remove all these names, countries, and areas. And finally, we said we have two arguments, deductive, inductive, and throughout until now we have talked and gave examples to both of them, but let's give a direct one and let's compare them. So deductive one here, and this is a famous example. All men are mortal. Socrates is a man, therefore Socrates is mortal. Here, as you can see, no matter what I put there, it is always going to be true, right? So this is a valid argument, right? It is valid, and as the premises are true, it is also sound. The main point of the deductive argument is, again, I will repeat it, if your premises are true and your argument has a valid form, then the conclusion is going to be always true. That is the key point. But we also have an inductive argument. So for example, let's get here. Sparrow is a bird and it can fly. Parrot is a bird and it can fly. Gull is a bird and it can fly. And you go here by hundreds and thousands of specimens. And if you do not find anything contradicting this idea, you could say that all birds can fly. Now, this is again a valid argument, but as you can see, it is not as strong and satisfying as the deductive one. Because if you show an assertion contradicting this, then it will just collapse. But there is no room for contradiction in deductive arguments. Again, considering that it is valid. Now, here I could say there are some birds which can't fly. Right? I could give an example about that. And then if I give that name, then this would be invalid. So science actually works with inductive arguments. So how does science then proceed? It does not proceed by giving right answers and confirming itself. It goes further by falsification. So all birds can fly is now considered true, right? But when I say that there is a bird and it can't fly, okay, now I just put this argument into waste and then I could proceed forward. Then I could say that birds actually don't necessarily need to fly, right? So inductive argument. But again, keep in mind that this is how all the branches of science work. For example, Isaac Newton's modeling of the universe were considered to be the absolute correctness because no one could falsify it. There were some arguments, they were valid, they were sound, but after a point, we saw that it was actually not enough. And then a chap called Albert Einstein came and proposed his idea. Of course, it is not that straightforward, and he's not alone, but just to keep the story simple, he put out his argument, and then we saw that Newton's idea collapsed. It is wrong. Absolutely. For example, he said that F equals ma. Actually, this is a false ramification of that idea. It is now in today's world revised and written in terms of in Einstein's relativistic ideas. And then some ideas of Einstein that also get falsified by quantum physics, some of them, but not directly, and they are still struggling to solve it. But as you can see, even if we counted inductive arguments absolute correctness, one day it could be falsified. But this doesn't make the science untrustable because in a universe like this, inductive arguments is the only way for us to get a true result. It may not be the absolute truth, but it is a truth which we can get to the nearest. So one day it is 70% true, the other day it could be 80%, 90%. So we are approaching there. And for now, this is the end. If you have any questions, please let me know. And if you have any recommendations on how I could improve these chapters, and if you want to see actually more, please let me know. And I hope that I have gave you some helpful times. Have a jolly good day.